joining. Let me share my screen so we can sort of prepare to get started. And in case it does blow up, I'll at least have the successful moment of a number increasing. So let's see. Population is set to 22. Building. Oh no, that's because you have, Dom Dorn, you have a keyboard plugged into your computer, I bet. Is that correct? External keyboard. Yes, you do. Shame on you. No, I'm just kidding. Yeah, I don't know why that happens with styles. It's the worst. I make a nice website, and then if there's scroll overflow, there's no way to get rid of that. It comes up the second you plug in a mechanical keyboard. You're trying to be a fancy coder. I think it assumes that people who have mechanical keyboards don't care about aesthetics, and therefore just throws an ugly scroll bar on everything. Yeah, I'm sorry, guys. It's a little bit of behind the scenes. If for the full aesthetic experience, unplug your keyboards. But there's probably a way to CSS that out. I didn't realize that would happen. I have not been using my mechanical keyboard. Supposed to arrive today, actually. So yeah, I got one of those. I spent too much money on a mechanical keyboard.
I know. I feel like I'm missing out. I just have my Apple keyboard.
Don't go there, Adam. Just stay happy. If you're happy, stay happy. I got RSI once, and then I, spent all my money on ergonomic equipment and got a weird keyboard with like divots and put your hands into these tubes, and it's weird.
I feel like that's the same thing with your post about Nix. It's like I gotta just stop going down these things.
Yes, I've got
time for ZIO.
Free time in my hands. All right, so we have 44. Probably some more people will start percolating in, but we can get started. So first things first, I'm going to try right off the bat. Let's just see if this is going to win or not, if we're going to have a good luck today. Last time, our app exploded, and Adam and I were going to talk about what we discovered, and hopefully can give you a great story of redemption and overcoming. But let's first see if it works now. And if it doesn't, we'll still talk about everything. And we have Tushar here, a master of actually deploying resilient production web apps, and we can ask him, why are we so unlucky? Let me know, guys. Connected via, if you could see the building as you have. This worked last time, but now there's a little population indicator up in the upper right, which seems to be changing, and I'm still connected. And if I hit the down arrow, do you see pretty things? I can imagine Dom Dorn with your external keyboard that looks really ugly. There's probably going to be a scroll bar next to each word, but hopefully for everyone else, it looks all right. Are people succeeding with the first step here? Yes. Oh, it doesn't even look like crap. Amazing. I wonder why that is. That's amazing. Nope, it's just the title. You lied to me. Oh, it's just in the title. Okay, just the scroll bar's in the title. Okay. Thank goodness. Okay, then we will continue. Redeeming a ZIO app, and it's actually going to work. Some motorcycles outside, very scary. And there's a bunch of crossed fingers. And I'm just interrupt me, Adam or Tushar, if this explodes for you.
So far, so good. Fingers crossed. Lots of them.
Yep. Lots of fingers crossed. We're going to go to this next slide. So what's going on here? This is a slideshow, everyone. And we have a slide model here. I talked about this a little last time, but I was kind of rambling. So I've made a visualization, which is going to be animated, which is we have a slide that we're on. That's this horizontal slide. And each slide is a step. So step 1 is going to reveal just the title maybe. And then step 2 is going to reveal some other content. Step 3, some more content. And these slide indexes, the slide index is what I call this just tuple of basically 2 numbers kind of, broadcasting from when I make a command to the server. When I hit a special admin command, it's being broadcast out to everyone, and then the server broadcasts it out to all you over WebSockets. So now if I hit it down again, now we're on the second slide, so we can switch between slide 1, step 3, and slide 2, step 1, etc. Obviously in the real world, we're on slide 2, and I don't know what step 8 or something. This is a simulation, meta. And everything is written in Scala, and I love Scala. Okay, so far so good. You can ask questions, by the way. Is everyone seeing all this? I'm gonna jump and see if we're all beautiful. Yes, it's working. It's working, and I can make it go back, and I can go forward, and we're having a great time. And are we having a great time, everyone? Is this working? +1. Oh, are you using some kind of CSS language in Scala as well? Yes, it's called CSS. We're just using regular CSS and also inline styles. I can get into the front end code later. That's a great question. So someone asked a question. I was going to get into this, so someone knows how. How is this so awesome? So thank you for your great question, intelligent question. If anyone would like to ask a question, what you can do is you can hit Control Q, but hopefully it doesn't quit your browser. If I did that, I don't know, it worked on my computer. It'll bring up this ask a question interface, and you could say, you know, what's up? And then you hit send, etc. Where's Worm today? Test question. Please don't post curse words or evil things, because everyone can see them here. And then I'll have to edit it with Final Cut, and it'll be annoying. Also, please don't DDoS the questions just now. But yeah, so if I go to a previous slide, perhaps, and then I can select a question, and it will, on everyone else's page, I should actually get up another page, another panel, and put these side by side, slide by slide. And so once I click on a question, oh, that's a great idea. I should have just done question. Next time we'll do question mark. Yeah, it's not a good shortcut. So how is Control Q a good shortcut? Also, this is all. So great point. It is not. So this is great. We'll actually use it. Also, by the way, the question is tagged with a slide index. And if you don't remember, that's this thing. So you can see next to each question on the admin panel, there's a slide index, and that's where you started. That's where you hit that terrible shortcut from. So the context of the question is coupled with the question. So when I click on it, we go to the place where the question was asked. So here was on the 0, 0. So we go back to the very first slide index and very first step. So it was actually expecting question mark to open the question, thinking, great idea, I will make that change. Or it's open source, you can make that change. Do you know who's asking this question? I have no idea. I have not added that feature. Another great feature would be sort of like GitHub OAuth and things like that, so that we can, you know, both prevent malicious actors, even though you're all being so wonderful. Where's Worm today? That is my cat, Worm, who is in heat. And actually, she's kind of cooling down. She's lukewarm now. She's still a little crazy. She's, I think, upstairs somewhere, probably playing with our other cat, or just napping. Test question. Great question. I'll get to that later. And more cats. Okay, so that's kind of the idea of the question thing. Feel free to keep asking real questions, and we can use that instead of the nice, cool. Even though this isn't really, this is basically, the slideshow basically is over. I'm glad it all works. There are two more things that we're going to go through. The first of which is we have a special guest who is Tushar, and he is awesome. And I don't have a second description for this, but there's Tushar. If you'd like to introduce yourself, I'll give you a better introduction than that, actually, and then I'll let you yourself some more, which is that you work for Dream 11. You're super friendly. You're super awesome. You're super nice. You're so great to like help us out and respond to some. You've written ZIO HTTP, which we're going to get into in a minute, which is a beautiful library, which we're going to look at the code for, and we're using it to run this, and it's very beautiful and fast, and you were very helpful, and I'm so glad you came to help us practice talking to people and interviewing human beings who are lovely like yourself.
Thank you so much. Yep, I mean, me and my team have been working on ZIO HTTP for quite some time. We couldn't find anything which has native ZIO support and performance, so that's how this library got built. I'm really looking forward to Z-Hub's integration, because that's one of our use cases in production. So this is almost something like this is what we are going to build for our apps at Dream 11. So really looking forward to this integration.
Yeah, no, it's very cool. I wanted some WebSocket features in order to do this stuff. And Tushar basically, like, by the time I was finished asking my question, he had already submitted a pull request. And it's beautiful. So yes, I've migrated from HTTP4S. We're going to take a look at the diff there. It is very nice. I mean, HTTP4S is fine, but there are some, if you're going to use ZIO, there are definitely some usability problems. And yeah, and this is also a lot faster, especially with ZIO at drop. There's a bit of an overhead there with HTTP4S for certain things. So next is this interactive DDoS section. Since we've done so well so far, I'm going to ask you what your preferred web server is. There are going to be some options. And you can just hover over them to change your answers. And yeah, and they'll be broadcast out to everyone, and hopefully things don't explode. But we've made it this far. I think it'll keep working. We'll see what happens. So make a decision, folks. Nice. All right, yes, of course. You guys are too kind.
Yeah.
You found out about it 10 seconds ago, and now it's your favorite. I do agree. And yeah, so the idea is that obviously on mine, it's a little, I could probably change the implementation slightly. I'm sort of batching up all of the different votes in the backend so that the backend doesn't get overwhelmed, but that's kind of creating like a bit of a choppy sensation. So this is a good test. I might actually just remove that throttling because it probably doesn't matter. And yeah, and when everyone's done, I'll lock it in, and then there we go, it's done. Now you can't vote anymore. Feel free to move your thing. So ZIO HTTP is the winner. Wow, maybe we're a little biased here, but Akka, it looks like, is second with HTTP for us. So that basically makes sense. Where's Worm? I already answered this question. Where's Worm today? Remember? I'll try to summon her, but you know, she's very loud, guys. We'll see if she comes down. I'll grab her. That'll keep you guys watching. So yeah, it didn't explode. I don't know what to say. I'm very excited. I thought it was going to explode. Are there any sort of Discord things? No voting? Just wait. Aha, it worked. Yay. Yes, voting. Sadly, this is the only vote here. The only vote segment. I think the actual slideshow ends here. So mostly a proof of concept. But yeah, we can talk about anything else now. We had some ideas of where to go. Want to ask Tushar a bunch of questions. Cool. Wow, I'm so excited. It's still working for you guys, right? Adam, Tushar, I'm not, I didn't go crazy.
Yep, absolutely.
Yep.
Okay. Well, lovely. So let's take a look at some code. Too many things open. Here is the slide app server. So here's the backend. This is what I did show off a little bit last time, and it has only been cleaned up with the use of ZIO HTTP. The idea is, let's go down here. This is the run function. There's this pickle socket thing, which we could talk about later. I will hide the pickle socket. It sounds really disgusting. I should rename that. What is happening? In the run function, we want to get the port number, right? Pretty standard. Standardizing on 8088 if that doesn't exist, that environment variable, then turn that into an integer. And then just in case that failed because there was a port environment variable that was some string, we turn it into just 8088 anyway. Then I print out, I'm logging all of the population stats. So if I tail on the server, we can take a look at that. Let me go here. So yeah, let me see, I think I'm no longer connected to the Heroku logs here. Yeah, so there's 63 users connected. If I open up a bunch of background tabs, we should see that the new connections get logged out, and we also print out the new number of connected users, even though everyone gets that broadcasted to them as well. So somebody left and then reconnected. Cool. Then we say we're starting the server, and then we get a config that has a special admin password that allows me to be the admin in it. That's on the Heroku server. And we start up our app. And this allows us to, this app thing is, if we look at the type, it's this HTTP type. This comes from ZIO HTTP. We're using two environmental effects, which is the console for doing some logging, and then also our slide app, which has all of the application logic. And we can compare this to the way you start an HTTP4S app, and we'll see that this is way simpler. And a lot of reason is because this is hard-coded, or not hard. Yeah, it's built especially for ZIO, so it knows about the R and the E parameters, and you can use those, and you can deal with them. We can start up our app, and as normally in ZIO, the environment is inferred in the for comprehension, so it knows that we need to provide a layer at the end of the world here that is our slide app and config. So it's really, really very, very nice. I think somewhere in one of these millions of tabs, I have the old version. It's right here. And we can see that sort of doing things with HTTP4S is a little less nice. you first need to grab yourself a runtime, and you need to parameterize that because this is a monofunctor, or like it's that finally tagless style of coding. It's not built for the environment parameter. It's not built for the error type. So you have to sort of make a type alias up top. And for convenience, you also want to make your append a type alias. And you kind of have to parameterize everything by that. So the environment doesn't infer. You have to plug it in everywhere and manually annotate types. Got to do some other weird things. It's all in the name of flexibility and being sort of unopinionated, but it's really nice when a framework is very opinionated, especially when it's opinionated towards ZIO, because it ends up being type inferred and really easy. You don't need to do any like acquire runtime stuff and turn the platform into an execution context, and I don't necessarily, turn things into managed and all that. That's all done before you. This is a sort of weird boilerplate. I think I mentioned last time that every time I need to do this, I basically open up the Caliban repository, because they have some good defaults in there. They have some example servers, one for each of them, and I copy that from there, and I'm like, yeah, okay, that's good. But it's way nicer to have a single line that just does it. Some other niceties of this. I mean, it also, nice thing is that it's not a huge diff, really. Besides, I just basically got to delete type annotations. I got to delete this, HTTP4S uses FS2 for its streaming. So for its WebSocket client, I needed to do this WebSocket builder thing, parameterize it by that app task. And then I needed to convert Z streams back and forth from FS2 streams, which adds overhead. It removes that type inference capabilities, because FS2 streams don't have, once again, the environment, the R or E parameters. So it's going to be slower, it's less ergonomic, right? It's not ideal if you're using ZIO stuff. However, if you look at the diff, if you look at the current code for basically doing that same thing, it looks very similar. Actually, it looks even sort of nicer. What we're building here, there are actually two sockets in the app. There's a user socket, and then there's an admin socket. So I separated out the admin commands, which are like changing slides and whatnot, from the user commands, which are, and I talked about this a little bit last time, so I'm eliding some details here. The user commands are asking questions, making votes, things like that. So the user socket definition is, it's this function that creates a random user ID, because this is going to be run on connect. And then when the user connects, it is going to, you have to return a stream from in here. So it's going to print out that we've received a new connection, which is all of these. So every time a user joins, it's going to print out that we've received a new connection. And then it's going to merge a bunch of streams together. Basically all of the state that I want everyone to be updated with. So the population stat stream, the vote stream for the votes, et cetera. So it's merging all these streams. And then I'm using a pickler, which is a library called boopickle, which basically just is really efficient and small and fast and better than JSON when it's basically a closed system. I have a front end that needs to talk to a Scala server. They're both written in Scala. They're both using Scala types. I can use, this library was specifically made for Scala and Scala.js for efficiently packing up, basically serializing and deserializing Scala types just into binary data that you can shove over WebSockets or over HTTP requests. And it's really small. It's not for like, writing a JSON server that's going to be consumed by end users, but for this use case where it's a closed world and a closed app that the front and back ends are going to be in sync with one another, and basically we want to pretend like it's a single server or a single code base, this works beautifully. So yeah, I just take all of these streams, turn them into this command ADT, serialize that, and it's deserialized in the front end. And it's really nice because you can compose together these different socket handlers. So handle open is this command here that's going to run when the socket is opened. On close, I'm going to call socket.close. I'm going to run this user left command, which decrements the population count. And then for handle command, I wrote this pickle socket helper, which will deserialize, depickle this command here, and then just give that to you. That's what pickle socket does. It's going to handle the pickling for you and return to you a socket that returns, well, nothing in this case, because I'm not returning any WebSocket frames or anything. I'm just taking the commands the user send and then processing them with my slide application. But as you can see, it sort of looks like the HTTP4S syntax. It really, I was able to delete code and make things nicer and do less translation between other things, that not have to do weird builder syntax and type parameterize everything. Got to delete a whole lot of code, and it's faster and works better. Okay, so that was a bit of a ramble. I should go back to the app and see if I've received any questions, because they're nope, just still where's worm. Cool. Feel free to ask questions there. I'll also check the Discord. How is ZIO HTTP handling normal HTTP? From what I got, it's basically just done for WebSockets. I don't think so. Tushar, could you take this this question that Dom Dorn asked?
Sure. I mean, ZIO HTTP initially though started off as a WebSocket only framework. At least since it's been open source, it has capabilities to serve normal HTTP requests. There are certain capabilities which are still lacking. For example, streaming and sending responses which are just raw bytes, and that's what we are continuously working on. And probably in the next few weeks, we'll see those capabilities also there in ZIO HTTP. But by default, any JSON, text, those kind of responses can be easily served using ZIO HTTP.
Yeah, and I mean, I didn't necessarily, I was driven to rewriting this mostly because, well, it broke last time, and I wasn't sure why it broke last time. And before I figured out exactly why it broke last time, I said, well, maybe it's the server. Let me try ZIO HTTP. And the translation was super nice. That turned out to not actually be the issue, I don't think, or at least not the full issue. But it was really nice, so I didn't want to switch back, and it turned out to be better. So I'm glad it kind of exploded last time, because I didn't want to try new things. I just wanted to get it to work. And then because everything exploded, I was willing to try new things, and it worked out very nicely. Are you guys open to contributions? Like I think I saw some issue in terms of that someone opened around query param matchers and all those nice sort of syntactic niceties for doing stuff like that.
Absolutely, absolutely.
So if anyone wants to help out with ZIO HTTP, it is like, I was surprised to see how far along it was, and even how much further along it came in just the last week when you were so receptive to the feedback. I'm very grateful. So yeah, and we're going to talk about the actual architecture of that later. There's another question which is saying that there were different poll results. There are different poll results, and I talked about this a little bit last time, but it was annoying because it wasn't actually working. As you can see, my polls are all empty now. And that's because there's sort of an event-sourced model here where when someone makes a vote, so I can unlock this real quick, and then people can vote a little bit. So there it's going, and I'll lock it again. So these are in sync, right? But now if I, let's say, refresh, or maybe but now if I unlock it again, and we vote some more, yes, it has votes. And it's sort of a subset of these votes. Because basically what happens is every time a user hovers over one of these votes, that vote is sent to the server with some debouncing. That server then aggregates all the votes it receives and groups them up into a chunk in a certain window. We can look at that code. It's in the slide app. It's just right here, basically. We have this queue of these votes. And then within every either 100 votes that are received or 300 milliseconds, it's then going to chunk all those up and then broadcast out a chunk of those votes to the front end, which will receive them. We could take a look at that as well. And then here what it does is when it receives the votes, this is going to be a chunk of votes, which is all automatically depickled for you by the WebSocket server. And then I'm filtering out the current user's votes so that things don't jump around. I kind of explained that last time. It's just going to process these votes on everybody's front end separately. So your vote state is going to be a result of folding over all of the votes that you happen to get broadcast to you. There is no canonical single source of truth vote state, which is a feature I purposefully left unimplemented so that we could potentially do it at some point in the future during one of these, or maybe via a pull request, or I could just do it in the meantime. But that could be an interesting one. But I wanted to, because this is a very interactive portion of this app. In fact, it's one of the most interactive portions. With a question, you have to sort of ask a question. This is going to be a bunch of people sending a lot of votes simultaneously. I wanted to not send out the entire map of votes to everyone and only send out those little diffs, and everyone could reconstruct the current state. However, we could also add another event to that little event stream, which is the current state or whatever, which could also be broadcast out when a user first connects, so that at least you start with the right state and then you get all the diffs so that everyone can arrive eventual consistency style at the right answer. But right now it is sort of purposeful that things can go out of sync. It'll be okay. They're sort of meant to be ephemeral, but that obviously is not perfectly ideal. Okay, I think that was all the questions, unless some more came in through here. Nope, it's still the same old where's worm. With that, I feel like there were a couple other things, or one other thing I wanted to talk about. Yes, there's one last thing I want to talk about, and then we can get to grilling you, Tushar,
Sure.
which is what went wrong last time? Why did things explode? And how we figured out that things exploded. Well, first, because I was lazy and I didn't want to know how to do load testing on the front end, I rewrote the web server from HTTP4S to ZIO HTTP, which was great and wonderful, but it didn't unfortunately fix the issue I was seeing when I opened a bunch of tabs in Google Chrome. By the way, I'll first show off my hacky load testing script. In Google Chrome, if you put your cursor up here, you can just hold Command Enter. Oh, this is Safari. Well, it doesn't work in Safari, so you need to do it in Google Chrome. And then you can join with a bunch of people simultaneously. This isn't good. And Tushar showed me a much better way of doing this. But this was good enough for me to at least break things. So I just opened a bunch of tabs and then closed the window and then opened all the tabs again. But we'll see that it kind of works all right. Anyway, everything's still working is most importantly. Changing the server sadly didn't fix the problem, even though it was a quality of life improvement and made the code cleaner. So then what I did was I wrote a test using ZIO Test. And the nice thing about ZIO and ZIO Test is that if since the problem wasn't the server, I knew it was probably something inside of the server, or every server app is somehow broken in the same way. So I assumed it was something to do with all of the logic, which was basically all contained inside of Slide App Live. If we go back to the Slide App server, it's delegating everything basically immediately to the Slide App. So this is an interface to the app, and it serves as a good way of sort of doing integration tests, not like the socket level integration tests or the full like connecting from an external client. But since the problem lived internal to the app and not at the boundaries, this was perfectly fine as an integration test. So what I've done here is I've written this function called simulate user, which prints out that it's starting. Then it chooses some random delay and then basically sleeps that amount to simulate a user potentially joining immediately or joining a little later, because I wasn't sure what caused the problem. I wanted to create some randomness. And then it takes some random number from between 2 and 5,000. It waits to receive 2 to 5,000 elements from a stream. When the stream function is run, the slide state stream, I'm just using one of them, streams in ZIO, Z streams can abstract over this thing called Z managed, which is this resourceful entity. So it can have an acquire and a release function. So just by the, what line? Simply by doing this, simply by merging all and calling each of these streams, when this effect gets evaluated, it's going to acquire a new subscription internally to the Z hub and receive events. And then when the connection closes and this is canceled by Tushar's logic inside of ZIO HTTP and the stream is interrupted or stops being listened to, it's going to shut down that connection. And that's all going to happen automatically for you. So that this is basically the idea of connecting and then disconnecting from a WebSocket. I mean, this is the actual outcome of it, is just calling the ZStream function. So just by calling this, it kind of simulates a user connecting to our WebSocket server, except only doing this bit. And then it takes that random quantity that it decided upon of elements from the stream. So it waits for like a user to hit next slide a certain number of times. In fact, at the very beginning of my test, I simulate the admin rapidly, frenetically hitting the next slide button over and over again forever, as fast as humanly possible, so that anyone who is listening will receive unlimited events that they want, but they're only going to wait until a max of 5,000 of these next slide events before disconnecting. In fact, they're not going to wait for those next slide events. Those next slide events are going to alter the slide app such that it's going to update its slide stream to have a higher slide index and then broadcast that out. And then it's going to disconnect. The way calling take and then run collect is going to work is that once it's taken the full amount, it's going to shut down its slide stream. And then what I'm doing is I'm getting the slide indices for each of those, because I'm collecting all of those slide states into a chunk and then getting the slide index. And then I'm making sure that it is all in the right order from the first, the smallest slide index it received to the largest slide index it received, so that the received slide indexes should be in order, starting from when they first got it to the end. That's just an extra sort of logical test. But really the problem was that things were just disconnecting. And so that's that simulate user function. And basically, so what I'm doing is I'm first hitting next slide forever, forking that off so that runs in the background. Then I'm sleeping for a second just to let stuff get weird and build up. Probably not necessary. Then I'm making a ref here, which is just used for printing out when things are finished. So it's just going to update the ref every time this is called and print out, you know, a one larger number out of a total number of things. And then for some total number of users, here I have 1,000 users, I can make this 5,000 users or something. It's going to simulate the user, so it's going to connect to the stream and collect all par, do that all in parallel. So all of these people are going to start connecting and taking their things, start disconnecting once they've reached their limit. And then I'm going to make sure that all of these were satisfied. And if we look at what this looks like now, we could take a look at the console outputs. We're going to see a whole bunch of, so we're going to see a whole bunch of starting, and then we're going to start seeing it complete as these receive enough. So finished, etc. So this is that report finish method, which increments the ref and then prints that it has finished. And it's going to go on and on. What I noticed after I ran this test the first time is that it never completed. Ever from around 1,000 on, it would never quite reach 1,000. It would be like 995, 997, and that sort of would increase. Certain streams were just disconnecting. Then I was able to sort of swap out one of the implementations and realize that the problem was with one of the implementations of a hub. The unbounded hub had some deadlock condition in it. If I switched to a bounded hub, it worked just fine. But yes, these subscription refs that we were using, and we kind of talked about last time, these use the unbounded hub. If we look at the implementation detail, they create hub unbounded. And so that was the one that broke. But if I copied this implementation, switched it to bounded, it succeeded. And the error was, Adam, do you want to talk about the error, or if there's something interesting there, or your thoughts on that situation?
Yeah, well, I mean, this is a little bit of the, I guess, the benefit and the disadvantage of, we wanted to demo it for you last week with the hub because we were about to do the latest release where we had backported it, and you know, we done a bunch of tests, but we hadn't actually kind of done it in a, I'll call a quasi-production environment. So we thought this would be a good way to test things out, and it was a good way to test things out. That we found out that something wasn't working, and it was one of those things where literally one line in the implementation of the unbounded hub was just had like misnamed variable, and so we fixed that, and then it was working fine.
Yeah, it was just literally like more of a typo than a bug. Doesn't even count. But now it's and then I basically used the snapshot version and swapped that in, and it worked perfectly. And that was the one that released. So luckily we did do this last week and we caught that bug. So in 106, right, 1.0.6 of ZIO. It does not have the bug in it any longer. And the test is really nice. Like, I don't know if people have used ZIO Test before, but it's a test framework that is ZIO aware once again, and it's asynchrony aware. I mean, you can clearly see that I'm forking things and doing things massively in parallel. And this is like basically a load test, except it's really easy to write. And I didn't need to like figure out any sort of third-party systems that open up a lot of browser tabs or hit Command Enter a lot. And this was able to flesh out the problem and then also reveal when it was fixed, which I thought was pretty fancy. All right, so that is the recap. It worked, hooray. This is how we tested it. That's why it broke. We switched over to ZIO HTTP. It's so much better. And now, Tushar, sorry for taking so long with the preamble and the recap, but it would be great to, like, we have all of these questions. I would just like to hear your thoughts at first. Like, have we ruined everything? Have we used it as intended? Have I destroyed your framework? What are your sort of high level conceptions? Is there anything you would change with this stuff?
I mean, if you're using ZIO, it's very difficult to use it in a bad way, in an incorrect way. That's one of the good things about ZIO. So I mean, if it was, it wouldn't compile. So I think this is great. It's being used the right way. In fact, I got a lot of feedback when you were using when you were implementing your WebSocket use case, based on which I think we are going to rework on the polymorphic type that you were talking about, so that we are not just collecting WebSocket frames, but you could create more domain specific pattern matches and then encode it outside your application. So into WebSocket frames. So that will be pretty powerful.
Yeah. So right now, all of these sockets have to return, in at least this snapshot that I'm on, have to return WebSocket frames. But where that might not be nice is if you want to not quite serialize it right away into a WebSocket frame, but process it in some other ways, such that you can maybe have a combinator that's just, pickle on the end of this that would then transform the socket. Because right now I need to sort of write this pickle socket method, which basically just does that transformation. So it allows for a more composable interface. I think that might be cool. So so how do you usually, because you definitely enlightened me from my sort of caveman era of load testing. I was just opening a bunch of Chrome windows. How do you make sure things aren't going to explode? Because the way I do it is I make a meetup and I invite a lot of people, and then they blow it up. And then it's hard because you have to, wait a week or come up with a new topic before you can run it again. It took 3 tries. My talk exploded. The first Symposium exploded. Now it didn't explode, huzzah.
Yeah.
But how do you do that more reliably? I mean, it's a scary thing putting something out there. Are there going to be malicious actors? Are there going to be the dancing Hulk? People are going to come and destroy your talk. How do you do that?
So there are actually 2 aspects to it. I think the first aspect is the way we do load tests. So typically in our environment, because we're constantly dealing with millions of concurrent users, we set up a production instance behind a load balancer, a couple of instances behind a load balancer, and then we have thousands of clients trying to connect, disconnect, and at the same time trying to send messages. And our use case is primarily a fan out use case where there's basically one message coming in, but we have to broadcast it to multiple users. And during that, at that very moment when you get a message, the CPU actually chokes up because you have to send it to maybe 100,000 users per instance. And at that time, if you start making more connections or there's something else that goes off, your system might just crash. So our load tests are designed in such a way that they mimic the most organic user behavior. So you're connecting, disconnecting, at the same time sending messages. Clients are creating idle connections, which is also a big problem because it creates memory leaks. So something which is very interesting about WebSockets, and probably when you start working with WebSockets, you start appreciating HTTP a lot more, because the number of ways you can screw up on a WebSocket connection is just insane. And you can create a connection, you might not close it correctly, or maybe you close it with the load balancer, but the load balancer didn't forward that TCP frame to you. And there's so many cases because of which your system can go out of memory, out of file descriptors, and it's pretty hard to really make a resilient system if you're serving WebSockets at scale. So the second part of it is making your application itself resilient. So one of the things that we do is after every few decent amount of time, we automatically close the connection from the server. This is done because sometimes when you're scaling out or scaling in and the capacity changes, we want the connections to get redistributed. So for that to happen, the clients need to continuously close the connection, because if you just deploy maybe 10 instances and the traffic increases and you deploy another 10, you want the load to actually shift to the new stack, which will only happen when you start closing the connections. Wow. The interesting thing is the way TCP works is it's possible that you close the connection, but the client doesn't acknowledge it. So the client is still connected to you, and you might actually be out of file descriptors or memory or those kind of things. So the client, we have put some logic on the client also to auto disconnect after some amount of time. So a lot of sort of patchy handlers have been added so that the connections close and you kind of release those resources that are allocated.
I think in this case, we're lucky that this is a single node. There's no distributed aspect. There's no rebalancing, and right. Probably never there will be like hundreds of millions of people, hopefully in some future world, hundreds of millions of people connecting to a Scala meetup. But in the near term, probably functional Scala meetups is a good way to naturally load balance or something. Do niche things, but obviously your company, what does Dream11 do, by the way? That's probably a good, what is the domain that you have so many people wanting to connect to you? Is it Go?
So it's a fancy sports platform, kind of like FanDuel and DraftKings in the States. So you basically create a virtual team of some players who are going to play on the field, and based on their performance on the field, you make points, and you can then compete with other people in your group, and those virtual teams basically compete.
And people like sports? They're into sports?
Oh, in India, cricket is very popular. So, and that's what happens. Like our traffic patterns are very unpredictable. And we know that there's going to be one max, but how big it is going to be and when is it going to be in that match, it's just very difficult to predict. So performance becomes really important for us.
Mm-hmm. Yeah, no, that makes sense. Yeah, I personally don't know anything about sports, but I do know, yes, lots of people enjoy them. And and especially with all those live statistics and tracking points, yes, it's like many, I can imagine live data streaming problems all together. And you mentioned earlier, you mentioned file descriptors, which is a good thing. That reminded me of something, which is in my testing, I thought we fixed the Z-Hub issue, but I was still running into this weird issue where I was, opening Google Chrome, holding the enter key, and then it stopped at 256. I couldn't get to 257. I was like, clearly, Tushar, there's a problem in your app. But then I went back to the HTTP4S version, and I was like, okay, HTTP4S is also broken. Everything's broken. Obviously, that's not correct. But it turns out you have a number of maximum file descriptors you can open on your computer. And that happened to be the magical number I was seeing as well. You can increase this, but just know that if you're testing WebSocket apps locally, you probably can't open up infinite connections. But that was a good thing to know. I scared myself that there was still some latent bug when there was not at all. So thank you for that knowledge. I would have never found that command. Launch control limit max files. What is the deal with this actually? Do you know is there anything interesting here about Mac? Obviously file descriptors are sort of a low level thing, and I know a little bit about them, but is this just for the maximum number of connections that you can have outgoing? I'm guessing WebSockets open a file descriptor.
Correct. Yeah. I mean, so for your case, because your server and the client were on the same machine, you were using twice the number of file descriptors.
That's why. Okay, I actually lied. I can open up to. I wasn't holding the enter key that long up until 128, and that's because each connection also opened up a second one. Okay, yeah. That makes sense. Okay. So yeah, one thing. I mean, I have a bunch of ideas, and if you have any thoughts, we can go in any direction. And let me know if there are any other Discord questions or anything like that, and I'll keep refreshing. But I was curious about obviously the speed stuff, like. Why? How did you make this fast? How do you know it's fast? Is it really fast? Do you promise? And yeah, we'll start with there. We'll definitely have some follow-ups there. But like, how do you know it's fast, and then why?
Sure. So when we wanted a framework, we started as even in the previous talk we talked about how HTTP4S was like the framework to go to, but in terms of performance, it really didn't meet our expectations. On the backend, we use a lot of Java, and most of the services in the backend are written Vertex. So that turns out to be the standard framework to use if you are on a JVM based stack. So we basically wanted something which is performant as Vertex, but at the same time gave you a purely functional paradigm to work with. Now, what we did with ZIO HTTP was to use Netty as its backend. Netty is exactly what Vertex is also using internally to power itself. So Netty is a framework mostly open sourced by Apple, and they've been working on it for a very long time, and it's a very stable framework to build any kind of network applications. It's not just focused on HTTP and WebSockets. You can do MQTT. You have a lot of other protocols, gRPC. Everything is supported out of the box by Netty. So we decided that we'll use Netty as a backend and give some sort of put some gluing code to give that ZIO API at the same time. But when you start doing this again, of course, now what happens with ZIO is every time when you're running a program, every execution actually goes to the ZIO thread pool. And especially if you have a program which is very small in nature, there's not a lot of compute or ZIO specific instructions to compute. It goes to the ZIO thread pool, and then once that's executed, it comes back to the Netty thread pool. So we basically have two thread pools. One is the IO Netty thread pool, and one is the ZIO thread pool for all the worker related stuff. And this continuous transition actually used to take a lot of time because you're constantly shifting threads. So we realized that whenever you're running a program, if there is a possibility of executing that program without going to the ZIO thread pool, we would just execute it in the Netty thread pool. And we execute it and get the response and write it. And without doing any kind of thread shifting, we just write the response on the channel, and you suddenly get almost like a 4x, 5x improvement in performance. So this is one of the things. Apart from that, the standard optimization that we could do, it's almost, so when you are, so if you compare Netty versus Vertex, Vertex has a bit of an overhead when compared to Netty. But what we tried to do with ZIO HTTP is we started partially evaluating the programs. And when you start doing that, you can actually, the effective execution path is equivalent to what it would be if you use bare bones Netty. So that's how we're able to get a lot of performance from ZIO HTTP.
How would that apply? So you mentioned if it doesn't use the ZIO effects, that it can be a lot faster because it doesn't have to shift thread pools. And also, I'm curious about the partial execution. In a case like this, would this get to benefit from that? Because I am definitely using, ZIO effects. Let's say in this user socket, right? Every time the user sends a command, I am executing an effect. Does that get bounced between the thread pools, or because this is like an ongoing socket connection, are you able to optimize this in some way?
So as soon as you start writing ZIO in your code, it's that execution has to go to the ZIO thread pool. I think there was some time back that when you would execute something, it would actually take the current thread pool and execute it. But I think now it automatically yields as soon as you get an instruction. The unsafe run, unsafe execute command actually has this yield now, which suspends the compute and just takes it to the other thread. So that if you remove that, then probably we'll be able to get almost similar performance. But because of this small piece, I think we as soon as you use ZIO code, anything which is a ZIO instruction, you will go to that thread pool, no matter how small it is.
Would you say, like, is this something that you'd have to be, obviously, if it's a hot path, maybe remove the effect code if it's something like that? But do you think like this would this still be fast? I guess.
Yes.
As stupidly as possible. This is still going to be pretty fast.
Yes, it would be. I mean, compared to, if you talk about those micro benchmarks, probably you'll lose out a decent amount of, throughput. But in real world, when you'll start comparing, you'll see this to be as performant as, a framework like Vertex. It's only those micro benchmarks where every minute amount of compute that you can save is being optimized for.
Sure, yeah. I mean, the users aren't going to be sending hundreds of thousands of votes per second, and yeah, most of the work's going to be done elsewhere. Okay.
This is also an area where in ZIO 2.0, that's going to be more efficient because there the execution model and the runtime is changing slightly, where the concept of having an executor is optional, where when you start executing an effect, we'll begin by executing it on the current thread that's running, and you obviously have the ability to shift it somewhere else, but that you have a little bit more control over. And so in some situations like this, we can avoid shifting unnecessarily there.
Okay.
And what you're saying, I mean, it's interesting because it's actually also very similar to some of the work we did with blocking, where I think this is a little bit different with Netty versus the blocking thread pool, but we had similar observations from users there where, like, if you kind of go back and forth between the blocking thread pool and the core asynchronous thread pool all the time, you can have a significant performance overhead of shifting back and forth. And so that's another area where I think we saw something similar, where if you kind of take a whole block of code and you do it on like the Netty thread pool or on the blocking thread pool, that can be more efficient than doing it at a very like fine-grained level where you shift back and forth all the time.
Yep.
That makes sense, because here all we'd be doing just to shift over, just to really update one little atomic ref. It's not doing this is not a long-lived, massively concurrent process right here. it's quite simple. So yeah. And why, so it compared to, like you mentioned starting to use HTTP4S and then sort of being disappointed with its performance, like why do you think that's slower? I mean, they're not using Netty, I'm guessing? Is it all handwritten? Why wasn't it up there? And I think it was even close to, not near Vertex, or maybe sort of towards the bottom, actually, unfortunately.
Yeah, I mean, per request, the number of allocations that HTTP4S makes is significantly higher. Also, the backend that they have their own backend, which is, and Netty compared to those, Netty is like, you can't compete with Netty in terms of resiliency and performance, especially on a JVM-based stacks. There are certain libraries which are faster than Netty, but they're more of prototype libraries. They're just beating on those micro benchmarks, and they basically, if you use them, we kind of also wanted to experiment with a library called Scalene, which is another pure Scala library, which is, I think, twice as fast as Netty, but it lacks a lot of features. It's not stable. We're still waiting for it to become stable, and probably eventually, if we can, we'll probably just rewrite the backend and change the backend to something more fast, much more faster, if it's possible. That's the idea. HTTP4S, you unfortunately can't, because it is extremely polymorphic in nature, because of which you end up writing a lot of code which executes at runtime, where you're just piping things along per request, per message, and it takes a lot of compute. So
yeah, I definitely think that's one of the lessons, is that sometimes, hard coding things and being slightly less abstract can make things a lot faster. One follow-up there then, because it's definitely something that I'm very interested in. It kind of ties to I don't know if John's most recent talk about writing really bad code is out yet. But basically, this thing that, Adam, you did in ZHub, which is you had this nice high-level, functional, composable, type-safe wrapper, really, of this really ugly, horrible, low-level Java. We can take a look, maybe. Let me pop into Hub real quick. So Hub internal. These aren't returning UIOs. This internal ZIO.internal.hub. This is returning, ints, booleans, chunks, unit. That's not functional. What is unit doing? And there are a few different implementations, actually, that are each optimized depending on the size of your hub. So if you just want a hub of one thing, well, then you get a bespoke hub that's built for one thing. He didn't decide to do every single integer, but so they're just then, maybe that would be a performance optimization. But if it's a power of 2, it can be more efficient. So let's stick with this hub. And it's pretty gross inside. Like, it's doing a bunch of low-level atomic operations on these atomic integer arrays, these low-level Java primitives. It's very cool. It's very gnarly. Clearly, like, Adam had to go into a meditative state. And we talked about this before, Adam. You went on, took some long walks. Like, it's not, sometimes you want to just code your way through a problem. With this, you kind of need to, enter a Zen state, get out in the sun, go to the park for a few hours. But this is the internal details, and you don't use this yourself. I mean, wow. I mean, it gets really, it's gnarly stuff. These are large, complicated functions, but you don't use this here. You use ZHub out here. In fact, this is as well another layer of abstraction, because this has too many type parameters for normal use. So this is aliased itself to another thing called, where's just a type hub, probably, right? Somewhere. Oh, that would be in ZIO Data.
Yeah.
So there is a type alias for this, just like there are for many ZIO types. For instance, if you've ever used ref is actually a type alias for zref that has 27 times the number of type parameters. You never need to know that, because I don't know, Adam and John and all the other core contributors are really good at dealing with variants, so that you never have to really realize that until you want it, but it makes things more composable. But we're just sort of getting further and further away from this really gnarly, ugly internal, yet you get to use it sort of invisibly at the high level, and it feels functional, and it is massively concurrent, and it's really fast. So you get sort of the best of both worlds, which is very high performance because of this ugly core, yet knowing how to wrap it correctly and knowing how to use variants and type level programming, you still get as though it were just a really poorly implemented combinator library that didn't care about performance. Like how, and that sort of reminds me of what you've done. You've taken this low-level Java Netty library that probably you wouldn't want to just use naked, which is the whole idea, I guess, for ZIO HTTP in the first place, is for wrapping it in a higher level. Are there any sort of lessons from doing that? How do you approach that problem? Like, where are the difficulties in figuring out that boundary and keeping the speed, but also keeping the abstraction? Are there patterns you've discovered? Are there difficulties that crop up? It's a very abstract question, but I'm curious, Tushar, your thoughts on that.
I mean, based on the library that you're using, for example, with Netty, you have certain patterns where you've got a message, you want to write it, but you also need to evaluate it because it's probably a ZIO message. So it's like a ZIO program. So a lot of times you're just asynchronously evaluating things. So you can kind of lift those abstractions into something generic. I mean, for Netty, honestly, it was significantly easier. It wasn't much of a challenge for us. And if you think about it, the gluing code might be barely 50 lines, maybe 100 lines at max. So it wasn't much of a challenge. So that's the best part. Like we just use ZIO and Netty. Both of them are extremely performant frameworks and very little amount of gluing code, and we could actually get it done. So I don't think I've done justice to your question, but I mean, that's how ZIO HTTP is. It's not a lot of very intense engineering really, but it does the job. It just uses the best of both the frameworks, tries to exploit that. That's it. Yeah.
Well, cool. That's a good answer. That it's easy, and that explains how you guys came out of nowhere then as well. So took two good things and peanut butter chocolate, and yeah. How about any thoughts there, Adam, about were there any difficulties with the hub Z-hub integration?
Well, I mean, I think maybe the first idea is that one of just having two different levels of, in that case, it was like the Netty level and then the wrapping level, or in ZIO, a pretty common pattern is to have some type of very ugly core, whether it's the ZIO runtime or the ring buffer or that internal hub thing, and then have a higher level interface based on top of that, and kind of explicitly separating those two versus kind of trying to do them together lets you really kind of do that low level part and make that very low level and make that efficient, and then do the high level part and make that very compositional and polymorphic and all those things. So I think maybe that's the first step. And then I think for Z-Hub, it was more challenging because kind of we didn't have Netty or the Netty equivalent for this, of like that lower level implementation didn't exist, and we had to kind of go and do that, which is that those different files that you were looking at. So there was a lot of kind of work in doing that, and I think there's also some just thinking about kind of what needs to get handled at different levels. Of like at the high level, we want all these things, and we want asynchrony, and we want callbacks, and we want the ability to like back pressure if there's like not space in the hub, or if we're trying to take an element and there's not an element available, versus at this very low level, it doesn't really support, it supports obviously concurrency, but doesn't really support that asynchronicity or back pressure. It's just, you're trying to get a value, it's either there or it's not. If it's not there, it's just going to return to you a default value. You try to publish. If it's full, it's just going to return false if it can't publish. And kind of that's like at that level. And then all those things about like back pressure and stuff are handled at the ZIO level. So kind of getting the right concerns at the right level, I think, is the other thing there.
Yeah, that makes sense.
To add to that, I mean, the high level abstraction, we need to make sure they don't have any performance penalty as soon as you start writing benchmarks, because it's very easy to write really compositional, really functional, abstract high level layer, but it ends up taking a lot of CPU time when it interacts with the lower layers. So
yeah, that makes sense. I'm sure it takes a little bit of practice to figure out exactly, as you were mentioning, like what should the low level version return? Like, okay, you're just returning a Boolean. How can that be used by the high level? How do you keep the low one churning as quickly as possible in a concurrent manner, but giving the information it needs and figuring out how to handshake that? I think that probably takes a little bit of getting used to. Is that something you feel like you've gotten better at over time? Because I know you've probably implemented a few of these low level things in the last years.
Yeah, definitely. I mean, I think there's kind of figuring out where you have like the knowledge to do something efficiently. Where like with the hub, one of the challenges that we had was implementing the sliding hub. which ends up being pretty useful because that's kind of models a pattern where if you have a slow subscriber, they're just going to drop messages and you're just going to keep pushing new messages. So it's kind of a nice thing to have. And for like the queue, implementing kind of a sliding queue actually ends up being pretty straightforward, where when you want to slide, you just take an element from the head of the queue and then you push a new element in, and that's what it means to kind of slide the queue. Versus for the hub, that ended up being significantly more complicated to do at the high level because you have all these different subscribers. And so essentially, if you wanted to do that at that higher level, you've got to go through each subscriber and tell them, we'll take an element if you're at full capacity, and that ends up being an ON operation, which you don't want to do. So that then kind of required going back to that lower level and saying, okay, well, we have this one array. How do we actually kind of just slide that array and make that a O1 operation, which again, okay, conceptually that makes sense, but then when you've got all these concurrent things going on, there's more thought that goes into kind of making that happen and preserving all the invariance you want to have there.
That is, yes, that is beautiful. If anyone wants a good time to look at some code, definitely check out the internals of Hub. It is far above my abilities at the moment, but you know, it is inspiring. Adam is a human being, God damn it, a really good human being. But he's we're all humans here, and I don't know. I think it's important to acknowledge that this is all very possible to do. Anyway, I've been feeling very inspired lately, so. Don't be scared of the hard stuff, even though that is very, very scary. And I'm so glad you've done it. And we can all benefit from the hard work. Yeah, it is ideal for this use case too. Is this kind of the use case you had in mind, these WebSockets, or are there other sorts of, I mean, there are probably many situations that are like this, but.
Yeah, I mean, I think it was overall the like broadcast use case where I think Tushar, as well as a couple of other users, came to us and they kind of wanted something like this. And kind of the traditional way this would be implemented is you would just have N queues. And so when you wanted to kind of broadcast a value, you would just go, and if you had 100,000 different queues, you just go and kind of drop the value in each queue, and then each subscriber would take values out of their own queue. And so that's like how the equivalent of FS2 is essentially structure, and that's like how that's implemented. And that's kind of fine in a way of like, it definitely like works, but it ends up being a lot less performant because you've got to kind of go around, you've got to offer it to all of these versus just having kind of one array that represents it. And I think it's one of those things where we, like, I think we saw that like broad use case of like broadcasting, okay, great. But I think also as we've like now kind of have the tool, we've like seen more like ways we can apply it, where like some of the straightforward ways were in the broadcast operators in ZStream, where those are now just implemented in terms of the hub. But then like another one is this subscription ref data structure, which we use here a couple of times. And so this originated with a feature request of essentially being able to like monitor the changes to a ref. So saying like, hey, like I've got a ref, it's great, I can modify it, but what if I want to see all the changes that occurred to it? And so we had a previous implementation where it was just implemented in terms of a queue. So essentially you write a value to the ref, it just pushes that value to a queue, and then you can read those values to a queue to kind of see what got written to the ref. And that was kind of fine for like a simple case of just like, you know, you've got one process that kind of wants to monitor what happens to this ref. But I think once we had Z-Hub, then we kind of realized that like that in a way wasn't ideal, where if you had more than one process that was trying to observe the values from that ref, you get this kind of counterintuitive situation where once one process takes a value, then it's no longer in the queue. So like if you have two processes, neither of them sees a consistent set of updates that occurred to that ref.
And that actually, sorry to interrupt, because that was the first version when I first implemented this. I used broadcast, whatever, before my first talk. And yeah, I would hit up and then one of the slides would change, but the other ones would all stay. And then it was sort of be this like round robin where one would get to the newest state because they're all taking off the current state from a single.
Right. The queue is great for distributing work of you've got a bunch of processes and you want to make sure each of them does one piece of work, but here you want all of them to see the changes. And so once we had the hub, it was very easy to plug the hub in there. And maybe if you want to, you can even go to like the subscription ref implementation, and it ends up being like, I mean, it's like super simple. But with kind of having that, it becomes like this like really kind of interesting, more general data structure where it's essentially the equivalent of like that like var that we looked at in Laminar, or like in like functional reactive programming, where this is something that now it's both a ref that you can change, but it also gives you this changes stream that you can subscribe to. And anytime you do, you're going to get the current value as well as all changes after that. So it's kind of a nice complement to the hub. Of the hub is kind of, it can be empty. You can subscribe to it and then you get all the values from then, versus the subscription ref is like always guaranteed to have at least one value. That's kind of the current state, and you get that and then you get everything after that.
Yeah. And most of the complexity here is just in this modify function. That's just to, I asked you about this before, and it's to, correct me if I'm wrong, but to make sure that when you subscribe, you get the actual, like the ref isn't changed out from under you as you're first getting the stream. So you do broadcast out the value at that period, at that moment of time. You could probably make it simpler if you didn't care about resiliency, but this is definitely the most correct way of doing it.
Yeah, exactly. So if you look at like in FS2, I think their equivalent data structure is called a signaling ref. And I think there's actually like a note in the Scala doc that like that may not be fully consistent, and like you need to watch out for that. So yeah, that was something we wanted to watch out for here.
Okay, cool.
And for our use case, because we had a similar use case where we had to basically do a massive fan out, and we started off with creating say 100,000 queues, and that was performing pretty poorly. And of course, ZHub wasn't there. So what we did was we created a single list using STMs, and basically you keep appending. There's a writer which is just depending on that list using and in a transactional manner, and then there are readers. Every subscription essentially is a managed subscription. So you just have multiple readers which are just moving forward on that single linked list. I'm really interested in comparing the performance of this system. This actually performed much better than those end queues, but I'm really interested in knowing how it compares to ZHub. I'm sure ZHub is going to be extremely fast compared to this,
really
but
yeah, you're obviously a very sophisticated and demanding user, so it'll be great to get your feedback.
Right. So one thing Adam I had a question about was during these fan outs, typically every message needs to be processed, and the typical flow is almost similar. Sometimes you get a message and maybe you want to convert it to JSON or perform some kind of operations. For our use case, if you have say n subscriptions, the compute actually happens n times. So that takes up a lot of time. Is there a way using ZHub we can just compute it once?
Yeah.
While pulling?
Yeah. So I think if you want to go to ZHub.
Yep.
So there's a set of contra map operators. So essentially with the ZHub, normal hub is just a hub of type A, right? It's a hub of whatever integers, and you push integers in and you get integers out. But you're also able to create these polymorphic hubs where you can push values of one type in and get values of another type out. And so you can transform both the input types and the output types. And if you transform the output types, then you're doing exactly what Tushar was saying of each time you take a value, you're going to transform that value with a function. And so sometimes that can be good if you want to like do logging for like each time a value is taken out and you want to perform some effect of like writing a log somewhere. But the disadvantage of that is like you kind of do that n times because you do it each time you take a value. Versus the other thing you can do is you can do it on essentially on the push. So every time you write a value to it, you can transform it. So you could have a queue that its initial underlying representation is a hub, that it's like a hub of JSON values, but then you could use this contra map to change the input type from being JSON to being your domain type by giving a function that encodes your domain type as JSON. And then every time you push your domain value, we're going to once at the beginning of the hub convert that into JSON, then it'll kind of sit there as JSON, and then everyone can just take that same JSON value.
Awesome. This is going to be really awesome.
Which actually, thinking about that exact case, I wonder if, now that I think about it, let me go to the slide app server. In this handle open, right, this is, the effect returned from this is going to be executed by everyone listening to this. So I wonder if it's actually possible to contra map on these streams beforehand to just get them already pickled, so that we only do the pickling when we put it in, instead of every single user connection. If there are, how many are there now, right? There are, oh, sorry. I mean, like every time I do like a slide change, everyone gets the new slide state, right? One of these things, it's broadcasting out the new slide state. So if I hit down, it'll go to, okay, now it's everybody who's connected, all 95 people are going to get that. It's going to run this function 95 times, which is kind of redundant, because that can just pickle them before putting them into the streams, or encode that. Obviously, that might make it a little less nice. I wonder if there's a way to encode that differently, or maybe I think that would be the case, but I could basically do that when I put it in, I think. Does that make sense, Adam? Would that be a potential use for contra mapping? I'm not exactly sure where I would throw that method.
Well, in this case, I think it might be just a matter of when we're transforming the stream, because essentially, I think what we want to make sure we're doing is we're doing the transformations before we're broadcasting the stream, because we've got kind of one stream of like all these values, and then we want to broadcast that out into end streams where one stream is going to each subscriber. So ideally, we want to do any transformation operators with the upstream stream, so that then everyone can just get that copy of the value.
Yeah, I think in this case that wouldn't be happening, but that would be an interesting thing to look at.
Something to look at as a follow-up, yeah.
For next time, or just a pull request or something. Because yeah, I didn't realize, yeah, for pickling it per user, kind of redundant there. It's all going to be the same, the same thing. Well, that's awesome. Were there any sort of Discord-y questions? Adam is a human being. Adam is a human being. Yeah, it's true. He won't say it. No, I'm just kidding. It's, by the way, it's hard to talk. I don't know any of the words that are coming out of my mouth. I hope I'm not sounding too crazy.
You're doing great.
Okay. I never really, just kind of letting it loose. I feel comfortable. My dog is staring at the screen since we're all human beings. I've offended your dog or given him ideas. You deserve more, Vigu's dog. You are human. Okay, I don't think there were any questions since the dog comment, so that's good to know. Yeah, I took some little notes here. Sending full stream on socket open. Oh, there was a little potential concern there. So yeah, in terms of like resilience to not exploding, which is something that I care about now that it's exploded so many times. I think one thing you pointed out to me, Tushar, was on socket open, I am broadcasting at all these streams. I actually asked you, hey, could I broadcast out streams on socket open? Because the API you had was just an effect. And I said, can I have streams? Because that'll make it slightly easier for me. But you did warn me that that might actually be an issue. Could you expand on why that might be an issue?
Sure. I mean, it's not a security vulnerability per se, but it makes your system a little more vulnerable in the sense that you're more susceptible to DDoS attacks. As we just discovered before the talk, that technically WebSocket requests are you can make cause requests. So basically, you can have a malicious website where somebody's making a WebSocket request to this website, and that will just go through, and that page becomes viral, and it's maybe embedded in some blog which everybody is connecting to. You'll suddenly have huge surge of traffic just connecting to your application and trying to make a WebSocket connection, and your server will start sending messages to it. A good idea actually is to not start messages unless the client subscribes and says, these are the kind of messages I'm interested in. That way you can also put some kind of limits around, make a system more resilient by saying, a user is allowed only 5 types of subscription at any given time. So as soon as the 6th subscription request comes on the same connection, you can kind of control it. And those basic, it makes your system a little more hardened in the sense it's difficult for people to actually break it down. Otherwise, people will keep making connections. You'll go out of, and you'll use a lot of compute If you just make connections where you're not sending messages you're losing out on file descriptors and memory, which is not going to be a lot. So you'll still be able to sustain that. So yeah, it's just a best practice that you can use.
So that's really good to know. And I think actually, and maybe that would be a reason to not accept a stream if you could force people into that best practice potentially. I mean, it is convenient, but and I thank you for letting me shoot myself in the foot, even though, I mean, it's totally fine in this case, even though we'll see in just a second if we can break everything. I actually want to give everyone a load testing script, and we can actually, now that things have worked, we can blow it up on purpose. But I think in order to get around that, what I did was I thought was a hack, but it sounds like your recommendation was I had another case, which is like, you know, let's call it subscribe, where I had the front end manually send this command and then this return the stream.
Yep.
So just basically delete that from there, put this in here, and then all handle open would do would just be calling this user joined effect or something to know that I have a user there. And then I wouldn't need it to be a Z-stream at all, potentially. So that actually seems interesting, if that might be a better practice. Because yeah, now people can't just do what we're about to do, which is just connect and start draining our server. And they'd have to, you know, you can still do it, but you'd have to do some effort.
Yeah.
You'd have to figure out how to serialize these commands and send them correctly and whatnot. But I think you were also mentioning how like DDoSing is always a tool. If someone's wants to DDoS you, you know, the internet, your doors are open. They can do it. But it's just a matter of making it less easy. So someone's DDoSing me now, I think. I'm going to share a, is someone DDoSing? No. Up to 100. Maybe somebody opened some new tabs, or maybe I did myself. So I'm going to share. Let's try to DDoS ourselves. If you have Chrome or Safari, let's destroy things. Now that we've made it this far. Oh, how many WebSocket connections can you handle on a single node? I have no idea. Let's find out.
We'll figure out.
Let's do it. This is a JavaScript. This is a JavaScript, and we're going to pass it there. At Dream 11. Well, we're not going to DDoS Dream 11 today. I'm just kidding. So yeah, if everyone can copy this, or whoever wants to try to destroy the app, I have here top running down below, and then also I'm tailing the logs up on top. And then if you run this, we should see also just the population number shoot up a bunch of times, which it is. And we'll see how long it takes for the server to explode. So that'll be fun. Maybe I'll also open up a Heroku. Obviously, each one of us can only open up a file descriptor number of connections, but let's see. Hopefully this doesn't like make Heroku angry at me or try to like shut down my server or whatever. But so far we're getting pretty high. And let me also try to reload myself. I can still connect and I can change pages. And let's see. Yep, it's still going. It's still going. I actually don't, the population little thing has probably exploded. I think we're actually in the thousands now. Yeah, we're at 1,000 something, I think. I can check the actual server. Yep, 12. So you're all doing it. So the population seems to get a little weird. Oh, is it broken now? Okay, no, it's sort of still going. It's a little slower for sure, but it's not down, which is cool. So I'm gonna go, today we're gonna build an interactive slide app with ZIO. Yeah, it's definitely slow and delayed. Maybe we finally broke it, but it's still connecting.
How much of that is like how many local connections we have? At least for me, I opened a ton and it got slow, but then I closed mine, so I just have one, and now it seems pretty responsive again.
Okay, that's true too. Yeah, I just closed a bunch of mine. But yeah, it seems to be pretty resilient. Yeah, it's okay. You're right. That could have been a local thing. I'm not sure. This one seems to be dead. Let me refresh it. Redeeming. Yeah, I'm still going with a lot of people. It's certainly not as fast as it was. But that's kind of cool. All right. Well, I'm glad that now we're actually trying to DDoS ourselves with multiple people. It's still staying resilient. So yeah, not bad, Heroku. And our number is definitely, I don't know, 1.4 RPS. I mean, that's not super high. I actually don't really understand how to read that graph, but our memory's doing okay. Staying at about a gig. Okay. Huzzah. So yeah, just one little node. Not too bad. Okay, we got some 2-second response time here and there by simultaneously connecting lots of people, but I think it's safe to say that we can keep using the slide platform for some time, as long as people don't use that script every day. And maybe I should, I'll make that change to do the connection not on open, so that you'll at least have to figure out the binary serialization protocol. And those are
actually, interestingly, if everybody closes at once, that also significantly puts a load on your server.
Oh, really?
Especially right, because you have a lot of close handlers that will all get executed together.
Oh, true, yeah, because I'm trying to decrement that thing, and I don't, yeah.
We got to close all the subscriptions, yeah.
Well, we're down to 8:49, but it's still connected, so the server's still working. We can still do slideshow stuff. Where's Worm? Nice, and we can vote still. Success! Oh, not okay. Now I think we all agree that. Anyway, that's super cool. I would have definitely been very afraid to try to DDoS on purpose, and we've even failed at doing it. I mean, the server's still running. The memory didn't go crazy. Check out the source code. It's a pretty simple app. Oh, someone asked me before one question about the animations. So that's a good opportunity to plug something else, which is, oh, well, there's this. This is the load testing version of that, performance testing. Did not want that one. I want examples. I made an animation library for Scala.js called Animus. And it's pretty cool. It's a Spring interpolation library, and I'm obviously using it for the slideshow for a bunch of the features for the animations and stuff, for many of them at least. This stuff and how those letters come in and everything smoothly moves around. And it's I think pretty easy to use, but we could talk about that some other time if people are curious about how that's implemented and how that works. But it's written for Laminar, and Laminar is kind of like a Z-stream. It uses these FRP concepts. I have a stream basically of doubles, and this gray box in the middle represents just that double changing every second to a random 360, 450, 120, etc. But then here I have the circle is that same signal, but I call the Spring combinator on it, which will get me back another signal of doubles that just happens to be Spring interpolated. Every animation frame, it'll try to go to that new value, which allows you to have smooth animations. And it's really nice for animating UIs with, because if you have some different case class that represents your UI state, like is this open, is this closed, you can map that Boolean value into some pixel value for the width or the height or whatever, and then Spring interpolate that value, and everything just kind of collapses and opens and rejiggers itself elegantly. So these little odometer things, all of that is Springified. Oh, and I can type whatever I want to type into this thing below. So that's a fun thing as well. But because I'm using Scala.js, that all works here, and it's all.
Does this use ZIO?
The front end currently does not use ZIO, although I have done that with Scala.js. I have this thing, which I show off all the time, which are these animations for ZIO effects, and it uses ZIO to run the ZIO effects in the browser. So it's the Scala.js version of ZIO to simulate ZIO, because there's no better library for simulating ZIO. Which is cool. There's some stream examples as well that I added recently for showing how mapping works and zipping with index and all these other fancy combinators. Definitely need to add more to this, but it's kind of fun. I like animations, obviously, so I'll post that as well if people are curious there. But I think we're about an hour and a half. Yeah, it's been an hour and a half, which I think is the time we've decided for this thing. But obviously, that was super fun. I'm so glad that worked. Thank you so much, Tushar, for writing ZIO HTTP and contributing, and Adam, and yeah. Any last thoughts or questions from anybody? I mean, we don't have to end it right away, but I know it is at least very late for you, Tushar, so I don't want to take up much more time. Looks like there are, okay, some thankses. All right.
Thank you all for coming.
Thank you. Thank you all so much, and we'll see you next week with something else. I don't even know what, but post stuff here, questions, we can get back to them asynchronously, and we'll see you next week with something. Contribute to ZIO HTTP. Go help out Tushar and use it. Bye, everybody.
Thank you, guys. Yep. Bye-bye.
Thank you so much, Tushar. Have a good night.
See you. Bye-bye.